Welcome back to my channel. Here we are still working on how we can determine the true length and true inclination of a given line in space. We are determining the true length and true inclinations of a given line in space. We have two methods, and the first method is known as rotation method, which we have used in the previous video. And this particular video now, we want to use the second method known as trapezoid method. The method is known as trapezoid method, and we are still going to make use of the same question that we used in the first video. Okay, I'm going to read the question again, and I will read it 2 times. Then we go on and look at how we can use this particular method known as trapezoid method to determine the true length and true inclinations of the line. Let us start. The question says a straight line PQ has its end P 20 millimeters above the HP, that is the horizontal plane, and 30 millimeters in front of the VP, that is the vertical plane, and the end Q is 80 millimeters above the HP and 70 millimeters in front of the VP. If the end projectors are 60 millimeters apart, draw the projections of the line, determine a true length and true inclinations with the reference planes by trapezoid method. I will take the question again. A straight line PQ has its end P 20 millimeters above the HP and 30 millimeters in front of the VP, and the end Q is 80 millimeters above the HP and 70 millimeters in front of the VP. If the end projectors are 60 millimeters apart, draw the projections of the line. Determine its true length and true inclinations with the reference planes by trapezoid method. That is the question. Now let's go and see how we can determine the true length and true inclinations of this line in space by trapezoid method. Now the first thing that we have to do is to draw a line XY line, that is horizontal line XY line, we call it XY line. So we are going to, this end is end X of the line, and this is end Y of the line. So we have this. The next thing that we are going to do is that we move away a little bit from point X, okay, or end X of the line, and we draw a vertical line like this. Then we take a measurement of 60 millimeters because we are told that the end projectors are 60 millimeters apart. So we take a measurement of 60 millimeters here. So this is 60 millimeters. So at this point also we are going to draw a vertical line. So here we have a vertical line. Okay, so I will need to extend this vertical line based on what we did in the first video when we used rotation method. So I will extend it here, and I'll also extend it down a bit. So here we have the line extended down. Okay, so this point here, so we are going to call this point. So this point here on XY line, we call it point O here, and this point we call it point O prime. So here we have O prime here. Now the next thing that we are going to do, as the question says that the end P of the line is 20 millimeters above the HP. So that distance that is above the HP, so we are going to take it up here. But before that, let me indicate the planes. So this is the vertical plane, okay, VP. So this is the vertical plane, okay, while this is the horizontal plane. So we have this to be HP. So let's take note of that, okay. And these views, as I said in the first video, are being made in first angle projection, in orthographic projection, first angle orthographic projection, okay. Now, end P is 20 millimeters above the HP. So that 20 millimeters above the HP. So from this point on XY line, you take it up the XY line in the vertical plane. So this is 20 millimeters. So this point is point P. So This is point P here. All right, so then we are also told that this same end P of the line is 30 millimeters in front of the vertical plane. So that 30 millimeters in front of the vertical plane, you take it down the XY line in the HP. So this point here is point P. Okay, so this one we call it P prime. Okay, next we also have that end Q of the line. The end Q of the line is 80 millimeters above the HP. 80 millimeters above the HP. So you take that 80 millimeters above the XY line in the HP. So this in the VP, so this is 80 millimeters up the XY line, and this point is NQ of the line. So we call it NQ of the line. So Q prime. Okay, we have it here. So the next thing that we are going to do is that we are told that the end Q is also 70 millimeters in front of the VP, So it takes 70 millimeters down the XY line here in the HP. So this is 70 millimeters. So this point, I'll call it point Q here. So here we have this. All right, so the next thing that we are going to do is that, so as we are told that we should draw the projections of the line. So projections of the line is by drawing this line here in the vertical plane. So this line is the front view of the line, and this line, by joining this point P and Q together, we have the top view or plan of the line. So we have it like this. Okay. All right, so we are drawing the projections of the line as we are asked to do. So the next thing that I'm going to do is that, so I'm going to draw a horizontal line from this point. So we draw a horizontal line from this point to here. So here we have the horizontal line, okay, from here to here, and also here we also have horizontal line from here to here. All right, so we have drawn the projections of the line as we are asked to do in the question. Don't forget that this method is trapezoid method. Now, the next thing that we are going to do is that we are going to draw a line at this point, at this point, at this point, and at this point, and the line will be at a right angle to each of, or to it will be at a right angle to this line. Okay, at any point. So the line that we want to draw will be at a right angle to this line, and also here it will be at a right angle to this line. Okay, so that is what we are going to do now, and to do that is very simple. Just take your protractor to make it easy for you. Take your protractor, so set it at this point and line on this line PQ. So at this point where we have 90, so make a point here where you have this 90. Okay, then do the same thing here by setting the protractor here at this point P here. Okay, at this point P, set the protractor like this, and then so put a dot on 90 as I've done it here. So if we come here also and do the same thing, so set the protractor at this point P here, so set like this at this point P, so make a dot on 90 as we have it here, and then bring it to this point, so set it here, and then set at this point Q here. All right, so put a dot on this 90, so we have this. Okay, so the next thing that we are going to do is that we are going to draw a line from this point Q here. I will draw a line through this point, so it goes like this. Okay, so coming here also at point P, so we set so we draw a line from point P, so through this point, so it goes like this. Okay, then when we come up here, we also have the same thing, so we have this. Okay, so we draw a line like this. Okay, and then coming up here, so at this point Q prime, so we also draw a line from point Q prime through this point, so we have this now. So each of this line is at a right angle to the line. So let's take note of what we have done. Now the next thing that we are going to do is that, so The next thing that we are going to do is very, very simple. So just listen to what I'm going to do. So with my compass, as we have here, okay, so here we are going to be taking the distance from this point O to this point P here. So just take this distance from here to here, okay, from here to here in the HP, okay. So the distance of this point P from this point O on XY line, take that distance like this. That is that 30 millimeters. I can just use my ruler to take that measurement, but I want to use the compass. So take this 30 and bring it here. So put the midpoint here at point P and make an arc here. So make an arc here. Okay, so this point now, so we are going to call this point, we call it point P1. So capital letter P1. So this is P1. Okay, then we also come here taking this distance of Q from point O prime on the XY line, which is 70 millimeters. So take it like this, okay. Then bring it to this point Q here. Okay, so bring it to this point Q prime here and make an arc here like this. Okay, let me bring it down so that we can see it. So I still need to extend this line. Okay, I need to extend this line. So we are using trapezoid method, okay, to determine the true length of a line. So with the distance that we have here, so this point here is point Q1. So this is point Q1. So here we have Q1 here. So I'm going to join these 2 points together. So point P1 and Q1, I will join them together, and this will be the true length of the line. So true length of the line. So this is true length of the line. So I will write true length here. So that is TL. So means true length. Okay. So that is what we have there for now. Now let's also get the true length here in the horizontal plane. So for us to get the true length in the horizontal plane, so we are going to take this distance of P prime from point O here on the XY line. Just take this distance. So from here to here. So take this down with distance which is 20 millimeters. So I can just take it with the ruler, but I'm using the compass. So take this distance and bring it to this point, okay. So make an arc on this line, okay. So this point here, we are going to call it point P. So this is point P, capital letter P here. So we have this, and then from this point O prime on the line, so take this distance which is 80 millimeters. So take this distance from here to here and then bring it here in the to this point Q here and make an arc here. So make an arc here. Okay, so make an arc here. All right, so I need to extend this line a bit. I need to extend this line a bit so that I can touch this. So we extend it here. Okay, so the next thing that I'm going to do is that, so this point here, so this is point Q. So here we have point Q here. Then we join these 2 points together to get the true length here in the horizontal plane. So this is the true length in the horizontal plane. So here we have this to be the true length in the horizontal plane. So we write TL. So this is the true length in the horizontal plane. So now, so let us write down the length or the measurement of the line. So here in the vertical plane, so we have what we have P. So P1, Q1, which is equal to the true length. Okay. Okay, so what is the measurement? We are going to take that, and also for here, so in the horizontal plane, so we have PQ, so is equal to the true length, okay, and is equal to, so let's take the measurement now. Let's take the measurement. So from what I have here, so if I take distance from this point P to point Q, so I have this to be 94, so 94 millimeters. So here is 94, so 94, so plus or minus 1, just write like this. And then if I come here in the vertical plane and take the measurements, so take the measurements here, so I have this to be, so around 94 millimeters. Okay, so I also have this to be 94. So plus or minus 1, 94 plus or minus 1 in the vertical planes, we still get the same thing. Now, so let's now determine the true inclinations of the line to the vertical plane and also to the horizontal plane. True inclinations of the line to the vertical plane and also to the horizontal plane. Now, in this case now, the true inclination to the true inclination as we have here, so true inclination to the vertical plane and to the horizontal plane determined this way. Okay, so what we are to do now, to determine the true inclination to the vertical plane. So because the distance that we used here, we took them from this horizontal plane. Okay, we took them from this horizontal plane. So the angle that we are going to get out here will be the true inclination to the vertical plane, because we took the distances that we made use to get these 2 points here. We took them from this horizontal plane. Okay, so the angle that we are going to get here will be true inclination to the vertical plane. So this is how to go about it. So what we are to do now is that we are going to extend this line. So you extend this line. So extend this line like this. Okay, then this line also, you also extend it. So let's do it. So extend this line this way, and then I will still need to. So let me extend this a bit. So it comes like this, and then so we also extend this line. So we extend it like this. Okay, so here we have this. So they meet at this point. Okay, so this point where they meet. Okay, so I'm going to put the pinpoint on my compass here. So extend it a bit, and then I will draw an arc between these two lines. Okay, so then the true inclination to the vertical plane is this angle that we have here. So I'm going to call it angle alpha. Okay, so what is the value of this angle? So true inclination, so that is angle alpha. So true inclination to the vertical plane, so is equal to, so true inclination to the vertical plane is equal to, so let's take the measurement of the angle. So with my protractor being set here like this, okay, at this point, so with the protractor being set here, so I have this angle to be 25 degrees. So the angle is 25 degrees. So true inclination to the VP is 25 degrees, and this is what we got in the first video where we made use of the rotation method. So this is the true inclination to the VP. So let's take note of that. So I said that we have this angle to be true inclination to the VP because the distances that we use in getting these points P1 and Q1 are taken from here on the horizontal plane. Okay, let's take note of that. Now let's get the true inclination to the horizontal plane. True inclination to the horizontal plane, same thing that we did here. So we are also going to extend this line. So we extend this line. So from here we extend this line. Okay, so let me take it up a bit more, and then we also extend this line. So we extend this line that we have here. So we extend it. So we extend it here, and they intersect at this point here. So then I'm going to use my compass to produce an arc in between this line like this. Okay, so I will call this angle, I will call it angle theta. So this is angle theta here. Okay, then with my protractor, if I take the measurement of this angle, okay, taking the measurement of this angle from here, okay, like this with the protractor, so I have this angle to be 40 degrees. So true inclination to the horizontal plane, so true inclination to the horizontal plane, that is theta. Okay, so it's equal to what? It's equal to 40 degrees, and this is the true inclination to the horizontal plane. So here we have used the trapezoid method to determine the true length and true inclinations of a line in space. As simple as I've done it here, all you have to do is to practice, and when you practice this, you become a master at this work. Thank you, keep on practicing, and God bless you.